Hi there. This is the video for lesson 3.1, increasing and decreasing functions. We are now going to use derivatives to identify different features of a given function. So let's look at fx. Yeah, there is fx. There is our original cubic function. Okay. Now, our job today is simply just to identify where this thing is increasing and decreasing. Okay. Well, if you were to, let me just erase this. Look at just the function itself, you would tell me that the function is increasing from here to here, and then from here to here. So in both cases, both section of that function, it's increasing in those two sections. Okay, that is also where the derivative is going to be positive. Okay, so if you look at the first question where it says given the graph fx equals x cubed minus 4x, which is the thing in red, when is it increasing? Well, it's increasing when x is less than, let's say, about 1.2, less than negative 1.2. So about right there, because not quite at negative 1, right? And where it's bigger than 1. Okay? Where is it decreasing? Well, it's decreasing in the middle of the two sections. So right here, it's decreasing right here. And we can say it's between negative 1 and 1.2 and positive 1. Okay. Now, looking at the derivative now, which is our blue graph, okay, which is our parabola, okay, you notice that this section here, the derivative is positive. This section here, the derivative is also positive. So, what is true about f prime of x when fx is increasing? Well, the derivative is positive. What is true about the derivative when fx is decreasing? Well, the derivative is then, then, well, we know that, come on. I don't know why it's doing that. You know, I'll switch over to the pen. There. So I know that this section here of the derivative, it's all negative, right? It's below the x-axis, right? That's also where my function is negative, okay? So think of it this way. Remember, the derivative is just the equation of a tangent. Equation is the slope of the equation of the tangent, okay? So here we can see the derivative is 0, okay? Because that's where it's at the very top, okay? It's 0. So if I were to draw a tangent, the slope of that dotted pink line is 0. Now, as I start going down, the slopes of the tangents start becoming negative. So negative, 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 negative. Gets to a point somewhere in the middle, about right there, where it's about negative 4, give or take. Okay? Which means the slope of a tangent, if I were to draw one right here, the slope of that tangent is about negative 4. And then it's still negative, but it starts to increase a little bit. So negative slope, negative slope, negative slope, negative slope, negative slope, until we reach a slope of 0 again. Okay? So let's apply this. And you can read this on your own, but it's pretty much stating what I just said, that we say that a function is decreasing when A, it looks like it's decreasing, or more using proper math terms, it's saying that when x2 is bigger than x1, okay, but fx2, or in other words the y value, is less than the y value of at x1, then it's decreasing. Okay? So in summary, for a function that is continuous and differentiable, it is increasing when the derivative is positive at that point. It is decreasing when the derivative is negative at that point. Okay? At f prime of x equals 0 at a specific point, then that is a turning point or a critical point of fx. What does all that mean? Well, let's take a look. For the function fx, this function, which is drawn for you, determine the intervals of increase and decrease. Okay, so now a graph is given. Okay, but let's pretend the graph isn't given. You know what? Let's use the fact that the graph is given to make sense of it, and then apply the derivative. So if I asked you, where is it increasing and decreasing? Well, we're going to look at the intervals. So intervals being right here, -1, okay, and 1. So we're looking at 3 sections of the graph. So we know that when x is less than -1, this blue section here, it is increasing. Then we look at between -1 and 1, so the red section in the middle, it clearly looks like it's decreasing. And lastly, the last section, when x is bigger than or equal to 1, it is increasing. Okay. Now, if we wanted to apply the derivative, what does that look like? Well, let's say I did not have the given graph. Okay. I know that fx is this function here. Okay, let's pretend the graph's not there. I find the derivative, and I get that using the power rule. Okay. Now, I want to find out where the derivative is equal to 0, because where the derivative is 0 means on the original graph, I have a turning point. Okay. Finding where the derivative equals to 0 is finding the critical number in order to find the critical point. And in this case, one of our critical points will be where max or min is. So I set this equal to 0, solve for x, divide both sides by 3, so x is equal to positive or -1. So I'm going to draw a table, -1 and 1. Okay. Then I'm going to choose a test value. So a test value is just any value within that interval. So choose a value less than -1. Well, let's just go with -10. A value between -1 and 1, let's go with 0. A value bigger than 1, let's just go with 10. Any value is fine. I'm just choosing numbers that are easy to work with. Then I plug those numbers into the derivative. Okay, so if I plug in -10 into the derivative, and I already did this down here, I get 297. But I don't really care about the value itself. I just want to know whether it's positive or negative. And it's positive. Plug in 0. Plug in 0 into x, and I'll get a negative value. So f prime at 0 would be negative. Okay, and then lastly, if I plug in +10 into the derivative, I'll get a value bigger than 0. This tells me that it's increasing in this interval, decreasing in this interval, increasing in this interval. Okay, so stating the answer, I would say, well, x between -1 and 1, it is decreasing. Okay, x bigger than 1, it is increasing. X less than, or sorry, greater than or equal to. Nope, I lied. I lied. I'll explain why in a second. X has to be strictly greater than -1, but less than 1 for it to be decreasing. Okay, so between those two, x has to be greater than 1 to be increasing, and x has to be less than -1 for it to be increasing. Why can it not equal to? Because equaling to 1 or -1 would be where the derivative is 0. Okay, so if it's at 0, it's not increasing nor decreasing. Okay, so the rest of this is pretty much the same thing. There's just a couple of examples. If you have any further questions about this lesson, feel free to shoot me an email. Okay, take care.